right, let's get started. Well, thanks for Chicago Jug, Bob, Cedric, organizers, volunteers. Thanks for Cars for having us here as well. Really appreciate it. And thanks for all of you for coming and spending your evening with us. So I want to talk about a topic that I think is something that's been around for quite a while in Java, but surprisingly, a lot of us seem to have somewhat ignored it. And part of the reason for that, I think, is it came at a time when something a lot more exciting was introduced in Java, which is the lambdas and streams. And obviously, with lambdas and streams, we're so excited about getting into those ideas. Completable Future was introduced right about the same time, and I think we kind of let it slide by. And I think it's picking up a lot more interest of late. So I want to spend a little bit of time talking about what are completable futures, what do we do with it, what problem does it solve, and how we could probably make use of it. And along the way, of course, we'll take a look at some examples and see how we can make use of it, learn about the APIs, but I'll also talk a little bit about Java 9, introduced a few new additions to this, so we'll talk about that too. Best time to ask questions or make comments is anytime you have it, so please don't hesitate or wait till the end. Anytime is a good time. Feel free to speak up. I'll be delighted to hear what you have to say. So let's get started with what problem we are really trying to solve here. Well, if you really think about programming in Java, I started programming in languages like C and C++, and then I kind of picked up languages like C#, Java, and many other languages along the way. But predominantly, I spent most of my time doing parallel computing, if you will. And asynchrony is something that I didn't spend a whole lot of time on. And honestly, when I started programming in Node for JavaScript, it was really hard for me to make the transition because my mind was thinking in sequential versus parallel, but to think asynchronously took a lot of effort. Well, in Java, of course, we've been doing parallel and concurrency for a long time, but I'm going to put my bet on this, and I have a feeling that in the next 5 years or so, we are not going to do as much parallel. We're going to do a lot more of asynchronous programming. There is a lot of excitement related to this. In the Java world itself, we are looking at continuations and fibers and Project Loom coming up in the next maybe 2 to 3 years. Kotlin has very strong support for coroutines. So a lot of interest is being put into the direction of asynchrony rather than parallelism. Well, but Java already has something to do with asynchrony from Java 8, which is really the completable futures. The name is a little bit misleading, so I'll spend a little bit of time talking about it, but the word future is a little confusing in my mind at least. But what does future really do? Well, let's step back for a second and think about Java from the beginning. What was the most popular API or interface we have had from day number one? If you really think about it, it is Runnable, isn't it? Now, what is the method of Runnable? The Runnable interface has one method which is void and called run. I want you to just look at that method for just 1 minute. If you ever start a thread, at least the initial implementations, when you start a thread, what do we pass to it? We pass a runnable. Now, one of the things we learned early on in time is we should avoid shared mutability because shared mutability is a really bad idea. Now look at the irony. What does the run method take as an argument? Nothing. What does it return? Nothing. How rude. It won't take anything and it won't return anything. So the only way you can use Runnable is by doing the very thing that we should never do, which is introduce shared mutability, right? So if you really think about it, this is predictably irrational if you think about it, isn't it? Because if you start a thread, how do you send a data to it? Well, you can't because run won't take anything. How do you get a response back from it? Well, you can't because run won't give you anything. So the only way you can communicate with it is to put something in the shared memory and say, you go get it and face the consequence of it, which is raise conditions and protecting that particular variable. Well, moving forward, of course, we started having a few other solutions to it. We had callable, and what does callable do? Callable will eventually return a response back to you. It still doesn't take any input, but will give you back a response. Well, then of course we ended up with what is called a future. So this comes to Java 5, where when you call a method, it can return some kind of a future back to you. Now this was exciting. Hey, if I call a method, it'll return a future to me, and that particular function can go off and do its work, and when it's completed, it would send the response to me through the future. That sounded like a great idea. So once you get a future, what do? You call this method and it gave you a future, and what's the next step you do? You could say future, and you could say dot get. And what happens when you call the get method? Well, you get stuck. There is really no future after that. And as a result, the irony is, future is something you call to have no future after it, and you're going to get stuck and wait on it to get the response back. And as a result, your thread cannot really do a whole lot until you really get the results back. So that didn't go really well at all. So we were kind of looking at this and saying, well, how do we really use this stuff? Well, we can learn a few lessons from JavaScript. I know that sounds scary, but truly though, we could actually look at JavaScript. Now, JavaScript has been dealing with this problem for a very long time. And in JavaScript, a lot of things are done asynchronously. You make a method call, and then of course, you don't block on it, you move on to do your own stuff. So it's a non-blocking call, and of course, JavaScript will go off and do its stuff, and when it's done, what does it do? It's got to get the results back to you. But how do you get the results back? Well, JavaScript typically used what are called callbacks. Now, if you ever think callback is a good idea, I've got a suggestion for you. Walk up to a JavaScript programmer and quietly utter the word callback and watch them begin to cry unconsolably, because they have scars in their body having used callbacks over the years, and callbacks have several problems with it. The first problem with callback is lack of consistency. Well, you make a method call, you get a callback. Well, does a callback have the first parameter as an error, or is the first parameter data? Well, there is no consistency. People do kind of different things, and depending on the library that you're using, some of them may give you a data, some of them may give you an error as the first data. It's really hard to deal with. Besides, what if the failure is before even the callback method can be stable? Well, you're not going to get an error through the callback. You may get the error from the call itself. Really not a good way to deal with it. And callbacks are really hard to compose. What if you call a method that gives you a callback, but within the callback you want to make another asynchronous request, and that's going to make a callback, and again a callback? Well, this leads to something beautiful called a callback hell. And callback hell is not fun at all. It's really very torturous. And like I said, it's really hard to deal with errors. So what did the JavaScript world do? The JavaScript world moved away from callbacks, and they introduced this idea of promises a few years ago. So what do promises really do? Let's talk about promises just for a minute. This is JavaScript promises. So promises deal with things a little differently. So let's take a promise for a minute. I'll just use the word P here for a second. So if I have a function, the function returns a promise to me. So I make a call to a function, and immediately I get back a promise. Well, you may say, is promise kind of like a future? Well, a future is an object, so is a promise is an object, but that's where the similarity really ends between the two. So what does a promise really do? A promise really has, I'm going to say it's got two tracks, if you will. So a promise has, I'm going to call it as a right track and a left track, or you can call it as a top track and a bottom track. But these two tracks really have a very special meaning. So if you want to think about these as two different tracks, a right track and a left track, if the promise is returned to you, and if the promise was, well, a promise is usually in three different states. A promise is in a pending state where it's still thinking, it's still working on stuff that's going to get the results back to you. A pending state could potentially change to one of the other two states. It could be in a rejected state where it said, I'm sorry, this is not going to be a successful event. I'm going to give you an error back. It's a rejection of a promise, or a promise could be in a resolved state where it gives you a data. So these are the three states of a promise: a resolve, a reject, and a pending. But once it gets to a resolve or a reject state, it will never ever change again. So those are the final states, either a reject or a resolve, but a pending is a state from which it could potentially change. But if this promise resolves with the data X, you go on the right track or the top track. Well, with that you can call another function that returns a promise to you, and that resolves, you go back to the next data, and you call another function that results again, and this is the happy path. You're just going on this right track and calling from a function to a promise that results to a promise that results to a promise that results. But at this point you call another function, but something really goes wrong. Maybe it runs into a problem, maybe there's an error talking to a device, maybe you couldn't get really access to something. What are you going to do? Well, this is going to result in an error at this point. The minute it results in an error, you're going to end up with a rejected promise. And the minute the promise is rejected, you no longer are in your right track, you go to the left track. So you're kind of switched over to the left track, and now you're on this error track. You could call a function at this point, and this function of course says, gosh, you have an error, let me see what I can do with it. Now clearly there are two options on your hand. This particular function may look at the error and say, I'm really sorry, this is messed up beyond any reasonable repair, there's no hope here, and it might blow up again. And that could go into another function which could again blow up, and you could continue on this error track for a long time. Or potentially you call a function, and this function says, oh, I've got a way to resolve and recover from this, and so instead of blowing up, it returns a promise that actually resolves. And at this point you no longer are in your left track, now you go with data to the right track, and you can continue forward. So in other words, if you want to think about an origin of function, and from the function you put two tracks in front of you, the data could be moving on the right track, something goes wrong, you switch over to the left track, you stay on the left track as long as things are still messed up, or you recover, you're back on the right track, and you could be just moving forward in the timeline. So this is exactly how promises work. So may resolve, reject, or be pending, and there's a data channel, and there is the error channel. So what I call as the right track is the data channel, what I call as the left track is the error channel, and you may get data through the data channel, or the error propagate through the error channel, and the failure or error is treated just like data. So this is the conceptualization, and it's extremely easy to compose. As you can see right here, that's just the functional pipeline. So you can draw this functional pipeline, and the data or the error can keep moving on the timeline from the left to the right in this functional pipeline, and that's how data gets propagated. So rather than throwing exceptions, you are propagating data or you're propagating error through the pipeline of functions from the left to right, and that becomes a really nice way to handle it. Now you're thinking, all right, that's all great, but why in the world are you talking about JavaScript promises? Well, this is one of the things that I realized, it took me a while to realize. When I started looking at the completable futures, I was very curious. I was struggling with it. I was asking the question, what is it? And as I started playing with it, I came to a grim realization. Completable futures in Java really are promises in JavaScript. If they had called it promises, everyone would know about it. So they said, no, we won't call it promises. We'll call it completable future, because then nobody would know what that is. So the point really is, completable future in Java is really promises in JavaScript. That's the reason I decided to call this talk as Completable Future, the promises of Java. So it's really, if you know promises in JavaScript, well, you already know the answer. That's exactly what Completable Future is, except for one difference. We know that JavaScript is dynamically typed, whereas Java is statically typed. So you have to work with the confines of the type system, and that poses certain problems and constraints we have to deal with, and that's what I'm going to spend the time on moving forward. So completable futures or promises really are dealing with stages. So what is really a stage? A stage is really a segment in this pipeline, and you put together these stages together, kind of like cars in a train. So you could have a train with 7 cars in it, you can have a train with 15 cars in it, and look at these stages as cars in the train, and the data just moves from one car to the next car to the next car in that pipeline of transformations, and that becomes your stages. When one stage completes, another stage is ready to run. And this is one of the ironies. I'll come back to this a little later. You are going from one completable future to the next stage to another completable future, another stage, and then you keep propagating forward. And so this becomes a series of transformations of your call. How does this really help us with asynchronous programming? Well, if you are going to make a call to a particular function, you can return a completable future. Well, the beauty of a completable future is when you don't have to call and get blocked on a completable future, just like a future. You can register with the completable future and say, hey, here is a piece of code I want you to run when the future resolves or when the promise rejects. And as a result, it will run without you having to block and wait on it. Now, one of the things to keep in mind is don't associate asynchrony with thread in your mind. And I'm going to show you that in just a few minutes, where it's a conceptualization, it's an abstraction, and we have to separate the abstraction in our mind from the implementation, because implementations can vary, but we need to really rely upon abstractions when we program. So let's look at an example of using a completable future and how it works through it. So here's a silly example I'm going to start with to understand how this actually works. So the first thing I'm going to do is to bring in, let's say, concurrent star, and we're going to create a function that's going to return a completable future. So I'm going to say here is a function called compute, and this function takes a value n, and all that it's going to do is simply return the value n. Doesn't do a whole lot right now. So let's start with a little silly example right now. Then what I'm going to do here is to start with the next function, and this is completable future right in here, which is going to be a type integer, let's call it that, and we'll call it as create. And then what I'm going to do in the create function right now is that I'm going to ask it to return a completable future. So return completable future dot supply async. So we are saying give me a completable future, but do it asynchronously. And within here, I'm going to give a supplier to it, and I'm going to simply call compute with the 2. So let's start with this little example. Nothing really exciting right now. We'll start with this little code to play with. So what does this really provide for us? Well, what this is providing for us is this is going to start with a completable future object, and this completable future object says, I'm going to start off execution for you on the background, and you don't have to block for that execution to finish. Obviously, this is a very silly code. It doesn't have anything to do that's going to take time, but don't worry about it. We're just calling this function and saying, you go off and do stuff for me, and I'm going to get back the response to you, and when I come back, I'm going to provide that for you. Let's go ahead and take a look at the completable future class. This was introduced in Java 8, as you can see right here, and this contains a bunch of interesting methods. One thing that to note over here is that completable future actually is implementing the future interface, and I'll talk about the consequence of that in just a few minutes with a little example and focus on maybe what we shouldn't really do. But what I'm really trying to call right now is the supply async. That's the method I want to really call, and the supply async is going to provide us for this particular method. Let's make sure I spelled it correctly. So this is the supply async function I'm going to use right now and say fire away and call that particular method. Now how do I use this result from this particular function? I could say completable future of integer, we'll call it as future is equal to create, and then this is going to give me a completable future on my hand. But I want to get the result out of that particular object. Here's a way you could do this. You could say future.get, and you could call the method on that object. Well, clearly Java says I have to catch the exception, but as experienced Java programmers, we know exactly how to deal with this. We'll simply say throws exception and be done with it right now. And of course, when I go back and run this code, what does it do? It gives us the result too. I want to spend a minute on this. There is a name for this call. This actually follows a pattern called bad idea pattern. So never do this. This is one of the things that is a consequence of inheriting from future, that you may be tempted to call the get method. And if you do, this is kind of pointless, because the minute you call get, you're going to get stuck, you're not going to move. So you should, they say never, but I would actually say don't ever do this. This doesn't really make any sense. If at all you want to really go this route, you could use a variation of this where it can take a timeout, and blow up. So you could use the version of get where you can blow up. But like I said, don't even bother going that route. Well, then how do I really use this? Well, before we talk about using this, I mentioned in here that this is like a pipeline of transformation, isn't it? Well, if it's really a pipeline of transformation, then we can think of yet another pipeline we are really used to, which is the stream API. And then of course you have the completable future right in here. And what are some of the differences and similarities between them? Well, real quickly, a stream is useful to transmit 0, 1, or any number of data, and a stream is going to push the data towards you. It's a lazy evaluation. A completable future, on the other hand, is not for a stream of data. A completable future either gives you one piece of data or gives you one piece of error. Well, we know that streams cannot deal with errors, right? It's not designed for exception handling. If somebody asks you, how do you deal with exception in streams? The short answer is good luck. There is no real good way to handle that. Completable future is designed to deal with one piece of data or one piece of error, and that's what it's really intended for. It is really a request and response. You make a request and eventually you get a response through the completable future. But having said that, in the streams API, there are some very common methods we use, like a for each method. And a for each method makes really good sense because a stream is dealing with many different values, 0, 1, or more. So for each of the values you want to do something, so that makes really good sense. The word for each makes really no sense for completable future, that we can see, because there's no each. There is either one or nothing, isn't it? But then how do we really deal with it on this side? Well, before we talk about it, I want you to think about for each just for a minute. Do you remember what the parameter type of for each is? The consumer, absolutely. Do you remember the method name for the consumer, the abstract method in consumer? Accept. Well, that's great. Now you know the answer. Because this is accept, the method here is called then accept. So now you know the relationship why these methods are named this way. So because the consumer's method is called accept, it doesn't make sense to use for each. So they decide to say then accept, that one value given to you. So now this makes really good sense why this method is called then accept. So let's go over to the code right here and say future dot then accept. If you give me a piece of data, I want to print the data right here and I want to display it. So notice that in this case we are displaying the data, but what's the difference? The key difference here is then accept is non-blocking. So when you call then accept, you're not going to wait for the response to come through. So I'm going to go over here and say done, and when I run this code, you can see it said to and it said done, and you're like, really? You said it's not blocking? Well, how so? Well, let's try this a little differently. I'm going to go here and put a little sleep on this one for about a second, just to keep it alive a little bit. And now what I'm going to do here is I will pretend that this is a task that takes a little bit of time to execute. So I'm going to sleep for about 1 second over here and execute that code. Notice I did not change anything here after all. But when I run this code this time around, notice the output that you're seeing right now. It says done first and then it says to. That's a proof that it's actually non-blocking, isn't it? So when you call the then accept, it said, great, when the result comes over, I will execute this piece of code, but I'm not going to block and wait on it. So it printed done and it went away. And a second later, that response comes back and it printed to. This really leads to something else we can actually play with here and try to understand how this works. Let's focus on the thread of execution. But before I show that to you, I want to emphasize, when you're programming asynchrony, try not to focus on the thread as much, because that's not the real intention here. The intention here is to be non-blocking. The intention here is to say that I am not going to waste my resource waiting on this to happen. I'm going to make a request. It's kind of like if I ask you, hey, what time is the train? You're going to say, let me look up and let you know. Obviously, you don't want me to wait on you. You want me to go off and do my own stuff. And when you find what the time of the next train is, I'm I'm hoping that you will come and let me know. This is exactly what asynchrony means. But is it a thread? I don't know. It could be a separate process. It could be a separate thread. It may not be even a thread. Like, for example, maybe be a separate thread. Let's look at an example here. I'm going to go back to this compute function right in here. Let's remove this one for a second. I'm going to say compute, and I'm going to display thread.current thread. So I want to know what thread is executing the compute method. Well, obviously the compute method is called within the completable future, which means that's going to set off a little task to run on the side. I'm hoping this will not be in the main thread, and that would not be a bad assumption at this point. But the question really is, what thread is going to run that piece of code, right? That's the next thing we want to know. So to find that out, I'm going to take the data, but I'm going to call a process function and pass the data to it. Let's look at the process function. So public static void process, that takes a piece of data, and what it's going to do right now is output the data, but it also outputs after this plus, and I'll say thread.current thread and print the details about the thread as well. Let's go to the command prompt and run this because it's a little easier to see the output. So when I execute this code, notice what just happened over here. Notice that the done over here is printing from the main. This thread is the compute method is from the common pool worker 3, and the code that printed the response to is in the common pool worker 3 as well. However, if you look at this code carefully, I did a print over here. Whether we like it or not, a print is time consuming, right? And the main is so impatient. The main says, I'm not going to wait for you to do that stupid print to the console. I've got better things to do. I got my own stuff to print on the console, right? So it moves on, and it's asynchronous. Let's remove this print for just a minute, knowing that that's going to run in a separate thread after all. So we'll remove it. At this point, that code is pretty wicked fast, isn't it? Well, because it's wicked fast, the chances are by the time I come here, it could have finished already. Possibly so, right? This is all purely speculation at this point. But if it is done, why in the world does this have to wait for that other thread? This could be done by any other thread, like main, for example. So if I were to go back and run this code this time around, we saw that was executing in the other thread a minute ago. Now notice where the process is running. The process is now running in the main thread, and the reason for that is by the time the main rolled here, that was so darn quick, it finished it, and the main said, I might as well just run this because I don't have to block and wait on it because it's already completed. The point I'm getting to is we should really not poke around with threads, because if we make an assumption that it's in a different thread, we would be wrong at least in a number of times. So it's important to keep in mind that this is truly non-blocking. Non-blocking doesn't mean you are multi-threaded. Non-blocking doesn't mean you are in a different thread. Non-blocking simply says you're not going to block and wait for no good reason. So that doesn't mean it'll be in a different thread. It could be in the same thread as we saw in this particular example. That's potentially possible as well. So that gives us an idea about the threading. But we also took a look at one more thing while we looked at this, and that is when I went back here and printed this thread information, we saw that it's coming from the common pool thread. Well, Java uses a fork join common pool thread, and of course the good news is there's a common pool thread. The bad news is it's common. So that means everything gets thrown into the common pool thread. What if you don't want this in the common pool thread? What do you want it? What can you do? Well, one thing you can do here is when you create your completable future, you could provide a pool here as a parameter. And if you give a pool as a parameter, then the execution happens in that pool. Don't take the code I'm providing here literally, but just to give you an example, I'm going to say public static fork join, let's say pool, and I'm going to say pool is equal to new fork join pool. Let's go ahead and create a pool here. And in general, you'd have to do more work to create the pool and to make sure it's destroyed properly. memory. I'm not focusing my effort on that right now. But if I were to go back and run this code this time, notice that's no longer in the common pool thread. It's in the pool that we created right here. So that's one way you can manage the pool of execution if you really wanted to. So that is something you could do pretty nicely, as you can see in here. So that's what you saw with this example. We can vary the pool of execution. Well, now that we saw this, we can be asynchronous, non-asynchronous. We talked about the then accept. That worked really well. Let's move a little forward. Now let's go back to the stream for a minute. You know that a stream has a method called map. So what does the map method of the stream really do for you? The map method performs a transformation of data. So if you have a stream of data, as the data flows through the pipeline, you can transform the data in a map function. Well, clearly map is associated with the stream. And what about a transformation I want to do in a completable future? Well, clearly all these functions are transformations, isn't it? Because it takes the input given and transforms to the output. And similarly, it takes the input given and transforms to the output. So I want to call it something. What would I call it? Well, you could have called it a map function in here, right? Because it's still a transformation. But of course, the promises API of Java, if you really look at JavaScript's promises, these functions used a special name here. Those were called as then. In fact, JavaScript has a concept of thenable. Well, these are traditionally called as then. So there is a bit of a tradition here in terms of what names we provide for it. And that is why it said then accept. This is as if saying, wait for the task to finish. And when it resolves, then accept it and do something with it. Well, then what do we call it over here? Once again, anyone remembers what the parameter type of map is? A function. And once again, what is the abstract function or function called? Apply. That's exactly right. Now you know why this is called then apply. So that is basically where the name comes from, is because you're going to apply that function and perform a transformation. Let's go back to the code and try this then apply and see how that feels. So if I go back to this example right in here, I'm going to take this data from the future and I'm going to execute it. And remember what it gave us. It gave us the response of 2. Let's get rid of the thread details right now. We don't need to see this, so we'll just print the data right now right here. So in fact, let's go ahead and get rid of that as well and simply say over here system.out println, and we'll just print it out when we get it. So give me a second to get this taken care. So println, and then of course let's get rid of this as well. We don't quite care about it right now, so we'll clean up a little bit and go back and remove this thread information 2. When I run this code, the result is 2. No surprise over there. The reason for the result to be 2 is that this is returning the input given to it, and of course this is printing the result. But what I'm going to do here though is I'm going to say over here dot then apply, and given the data, I want to return a twice of the data. Now notice what we are doing. We are transforming the data. So the future dot then apply, given the data, double it and then accept it and go ahead and print it. So if you run this code, we have a 2 coming out of the compute method. 2 times 2 is 4, and we should be printing the result of 4 in this computation. So obviously in this case, it's a silly example where I'm returning a 2, but that could have gone out to a service and gotten maybe a customer's balance, or it could have gone to a service and gotten the customer's credit limit. So these could be bringing it over, and you could be performing a transformation of the data that you got asynchronously, and you can do the mapping. So the then apply is like your map function, and then accept is like your for each function. You're drawing that pipeline through this asynchronous call. So the data 2 comes through, and you're able to double the 2, and you get back the result of 2 times 2 is 4, and you are printing it out. Well, it turns out there is also one more thing you have here, which is a then run function. Well, what does the then run function do? Well, the then run function, there's no quite equivalent of that in a stream, isn't it? Because a stream is going to give you a data. You don't do anything in the stream without a piece of data. Well, but why would you want to deal with no data in a completable future? Well, the reason for that is you have a completable future right here. What is the type of the completable future in here? This is a completable future of integer in this particular example. What does this give you in return? This is a completable future of double if I were to say dot 0 right here. What that brings up the question, what is this in here then? Well, this one here is a completable future of void. And the reason it's a void is the then accept is going to take the data. Remember, that's a consumer. Remember the return type of the consumer's accept method. It's a void. So the accept is returning nothing. As a result, this completable future is a future of nothing. Well, this gives you an idea. The completable future didn't terminate over there. Now what can I do? I can now say dot then run, and in here I could take nothing, it's a runnable, and I can print out something like this. I could say it is over. So in this case, I'm going to run this code. It printed 4.0 and it said it is over. But here comes the irony of a completable future. A completable future never completes. It's like the Thanos in the movies. It doesn't matter. You see the movie and Thanos is back in the next one and in the next one. It's kind of that kind of a villain, right? It never dies. You can never kill it. So if you go back over here and then you can say then run, and you can then say over here not really, right? So it's over, but not really. So if I run this code, and you will notice that in this case, it's not really over because the completable future survives beyond it. And you can go further, and you can say over here, then run, and you can say in here, well, it keeps on going, right? Keeps on going, there is no end to it. So trying to put an end to it is like trying to wait for eternity. There is no end to it at all. So this is going to be a completable future that returns a completable future that returns a completable future. It's kind of like a train. You get on the train when you want to get on, and you get off the train when you want to get off. You don't care about where this train started. You don't care about where this train is potentially going to end. Maybe it never ends. It goes in a circle, right? But the point is, you are looking at a segment, and you get on here and you get off over there, and then you can keep going with it. So that is how the completable future is built. It always produces another completable future. At some point you're like, I'm done, and you move on. You don't ever wait for it to finish entirely because it keeps going. So every step it can produce another completable future, and you can continue with it. Now, we saw how to use these methods. Let's go ahead and look at how to build a pipeline and use this. And I haven't still shown you the exception handling in here, but we'll come back to that in just a little bit and see how that we can use that. So let's start with a little example and play with one other way to deal with it. So let's go ahead and create a method here. So I'm going to bring in the concurrent again. So let's go ahead and say we have a method that is going to receive and work with a completable future. So I'm going to say process, and the process function says give me a completable future, and this is going to be a completable future of integer, let's say, and I'm going to say this is the future or promise. You can call it whatever you like to call it. And what am I going to do within here? I'm going to say the promise dot then apply, and give me a data. I want to return a data times 2.0, and then I will say over here then apply, then accept, and I'm going to simply say system.out and print it. So this is a little pipeline I built in to do some processing with it. So maybe you are asking for a customer's balance. When the balance comes up, maybe you want to pass the through, and decide whether they're eligible for certain promotion, what have you, or you want to perform other checks, whatever that could be, whatever process you want to perform based on the response you got back. But how do I use this one? So completable future integer is equal to new completable future, and notice that I've created a brand new future object. In the previous example, I called the supply async and I said go do this work, whereas here I'm going to just create an empty completable future and call the process function and pass the future over to it. And as you can see in here, that pipeline has been built for you and it's ready to do the work, but you are going to go off and do something else to actually get the data. So what am I going to do now? Well, in here what I'll do is I'll take a little siesta, let's say sleep about a second, and after a second delay what I'm going to do here is I'm going to call pretend that I did some work here, and I'm going to say future dot complete, and I'm going to pass the value 5 to it. Now when I call the complete function on the future, now this could be entirely another asynchronous operation I could potentially call into, and when that finishes the work I could then push the data through this pipeline. In other words, we have a pipeline that we have built here, and the pipeline is like a track that's been laid and you're going to pass the train through it. So you are ready to push the data through the pipeline, and that's what you're doing here through this pipeline by calling the complete method. Then I'm going to sleep for about 2 seconds after that, and then I'm going to simply say done to say that I'm done with this process. But if I go back and execute this little piece of code, what does that provide for us? Notice that it said 10.0 and then it said done. So how did that work? Well, at 1 second later, we called the complete. The complete pushed a 5 through the pipeline, and the pipeline took the 5 and doubled it, and as a result is a 10.0 which it printed, and that's why we saw 10.0 being printed. And then of course in here, after sleeping for another 2 seconds, we printed done and we were done. So this is an example of how you are able to build a pipeline on one end and push the data to it on the other. Well, that's great so far, but what about exceptions? If things were to go wrong, we need to be able to handle those. How do we really do this? Well, remember one more time what's going to happen here. If something were to go wrong, you're going to be in the bottom track or the left track. So in other words, if a completable future rejects, you're going to take a different path than when the completable future is going to resolve. In the case of JavaScript promises, you have a then, but they use the word catch for the path where you're going to have some errors. Well, we know that catch has a special meaning in Java already. Catch is a keyword. Well, calling it as a catch makes it a little hard, but even if you were to call it as a catch, how do you really deal with this particular exception? How do you propagate this exception? So they decided to do this a little differently. I have to admit I'm not a fan of the method name they chose, but that's what they have chosen. So how do I say something went wrong here, and how do I deal with that unhappy path? So this unhappy path here is actually called as exceptionally. I'm not even kidding. So you say exceptionally and you provide the unhappy path in the saying throwable, and you can call a handle and pass the throwable to it. So you can see in here, now the promise has 2 paths over here. Now unlike this over here, where I can nicely show you the right and the left path, you can't quite do that so easily in the code. So the way you have to read, you have to kind of squint your eyes and see this. Everywhere you see exceptionally is the bottom path or the left track, and everywhere you see the then is the right path. And so you have to kind of skip code when you read it. So if you want to only see the right path, don't look at the exceptionally, only look for things that start with a then. If you want to only see the left path or the error path, don't look at the then, only look at exceptionally. So these are the two paths, but they're kind of intertwined, and you have to kind of, look one versus the other. You have to read the lines depending on whether they start with then or whether they start with exceptionally. So in this case, what am I going to do with the exceptionally? Well, let's go to the handle function for a minute. So in this case, I'm going to write a public method, public, and this is going to be static, and I'm going to call this as handle, and this takes a throwable, if you will, and the throwable, what does it do with it? I'm going to just output right here the throwable that we got. So I'll say error colon and then plus throwable. So, but the question is, what should I do next? I want you to pay close attention to the return type of handle. Now this is because Java is statically typed. Now remember, what is this then accept expecting on its left side? On the left side is expecting a completable future of type T, where the T is going to be the type of this data. In our example, it's an integer. Well, if it's an integer, then the exceptionally should be returning back an integer as well, and that is why the return type is int. If this were not an int, if I make it a void, the code won't compile at this point. As you can see, I get a compilation error saying the bad return type in lambda, and it's not happy with it. But if on the other hand, if I put an int, it's like, okay, I'm happy with this because your completable future is going to receive an integer, so this better return an integer, right? So you have to decide on the return type that you're going to continue the pipeline. That is a little unfortunate because when you go through this, the type here should match the type here. But it's also reasonable because you can remember this could either blow up or it could return a promise that resolves, isn't it? So in other words, that particular exception you're providing could be this one where it continues to blow up, or it could be this one where it actually puts you back on the right track with the recovering and saying, I'm all right, I recovered from it. So going back over here, let's go ahead and say return 100. Now, what does that really mean? Well, maybe you are trying to make an asynchronous call to find some particular property for a customer. And you run into an issue, you couldn't find that property, and now you're thinking, gosh, I couldn't get this data. I could tell my user I can serve them, or maybe I can substitute a reasonable value. Maybe it's a coupon discount you're providing. You want to know what discount to provide to the customer based on their past purchase history. Maybe you're not able to get to that information, but you don't want to let go of the customer. Maybe you can give them a different discount just to keep moving, right? Or whatever the business scenario, maybe you can decide it. Now in this case, when I run this code, we are still in a success scenario. As a result, you got a 10 and it is done. What does that tell us? Well, our code completed successfully with the 5, and when you finish with the 5, what happened over here? This resolved with the 5. Because that resolved with the 5, you literally stepped over that exceptionally, right? Because you don't want to step into that pit, and you went directly to then apply. Because you're not in an exception situation, you bypass that. So you go to the then apply, multiply the 5 with the 2.0, that's a 10.0, and as a result, you came here and printed. But what if something were to go wrong? What are we going to do? Well, let's go ahead and say something is going to go wrong. So rather than completing this, I'm going to say future dot, and I'm going to send new runnable. And what do I want to say for the runnable? So the new runtime exception, right? So runtime exception, and what kind of exception do I want to say? Let's send an error like we often see in production. Something went wrong, right? So that way we can tell that something really broke. Now, what do you say? How do you really send this across as an error? Well, this is the next method, which I'm not too happy with the name, but this is even better than exceptionally. This is called completed exceptionally. So this is something you need to keep in mind, because once programmers figure this out, this is one thing you can do very nicely at work. The boss comes to you and says, How are things going? And you tell the boss, I completed it exceptionally. And the rest of your team will understand what you're saying, right? So beautiful method name. So that's what I say these days. When they ask, how's it going? I say, completed exceptionally. And then the programmers around me know exactly how things went. Well, the point really is we're going to blow up right now with this exception called something went wrong. Well, what's going to happen now? Well, notice we didn't complete successfully. We didn't resolve. We are rejecting. And because we are rejecting, it is going to get into this exceptionally. And what does that do? It prints the error saying error, something went wrong, but it says, you know what, I can recover, and returns 100. And because it returns 100 after printing that error message, we're going to take the 100 and double it to 200, and we're going to print the 200. Let's see if that's true by running this code and see what the output says. Well, actually, in this case, we got to do a little bit more work. What's going on here? Runtime exception. Cannot find the symbol. What did I do wrong here? Completed exceptionally. Yes, thank you. So completed exceptionally. I have to spell that correctly. Hopefully I got that right. So when I run this code, no. So completed. Let's try this. Sorry, complete exceptionally. So let's try this again. So when I run this code, what does it do? Well, right there it says something went wrong, but then it's a 200, as you can see right in there. So the point really is you had a promise, a completable future that rejected, and you handled that exception, and then you said, I'm going to give you an alternative response so you can move forward. So this is like in your catch, you normally do a catch, and then you say, well, if this is what happened, I'm going to send back this other response. It depends on the application. That may be something you could do. Alternatively, what you could do here is to say, throw new runtime exception, and you could say, this is beyond any repair, right? So you could simply say at this point, sorry, this is too broken, I can't do anything. The return type is still int, but you blow up at this point with another exception. What's going to happen now? Well, at this point, in this example, you came with the promise and that rejected, so you are in the bottom track. And what did that do? It simply gave you another error. And as a result, you're going to keep going on the bottom track, never to go to the top track anymore. And as a result, you are going to step into this pit, and you're going to display that error. It's going to blow up, and you're going to completely bypass this and leave at this point. So when you go back and run this code, you notice how it says error, something went wrong, and that's it. No 200, no response from the then block. So the thens are no longer called because you are in a rejected mode, and you continue with the rejection moving forward, not to come back to the right path at this point. So of course you can put another exceptionally if you wanted down the lane, and you can deal with that exception if that even makes sense to do. So you could have multiple of the thens. Similarly, you can have multiples of these exceptionally as well, and you can build your pipeline. So that gives you an idea about how we can perform this chaining of these operations, and you can move it forward. So this is all available in Java 8, except that Java 8 had one strong limitation. And if you look at this code right here, you have a pipeline that you have drawn, and in this pipeline you have an exceptionally, and you have a then, so you know what to do with the data, and you know what to do with the rejection or the error. And of course, once you build the pipeline, your task could take the time to execute. When it finished, it sent the data, or it couldn't finish, it sent a rejection. But what if you were to make a particular call and something absolutely fails in a completely different asynchronous thread, and you're not going to get the response back on your side? You're not going to get a completion, you're not going to get a rejection, you're not going to get a resolution either. So what happens in that case? Well, unfortunately, it can lead to a situation called a live lock. So what is a live lock? A live lock is where a particular event that you expect to happen may never happen. So imagine a request comes to your server, and you wanted to find out what a customer's balance is, and you send a request. And when the response comes back, you're going to go back and do more work and maybe send an email to the customer or update another system. If something went wrong, you're going to deal with it properly. But what if you don't get a response at all? Maybe it's taking longer, but how long it's going to take? I don't know. What if it's taking forever to respond? Well, that kind of leaves your system in a pickle, isn't it? Because your customer support eventually gets calls from people saying, I made this request, but I never got a response. Your system said I will receive something, but I never got it. This is like some sites where you go and they say, sign up, we'll send you an email, and you keep waiting and waiting. There's no more email coming through, and you're like wondering what's going on, isn't it? So in other words, what do we do about it? Before we talk about it, I want to mention a philosophy of life. And I'm going to say this is true for life and this is true for programming. So I'm going to say both in life and programming, never do anything. Well, actually, we could even stop right here. That's a good philosophy too. But never do anything without a timeout. So this is something we should absolutely follow when it comes to both life and programming. Never do anything without a timeout. And I always tell young people about it, a life wisdom I share with them. For the young ones who are looking for perfect love in their life, I always tell them, if you're going to look for a perfect love, always put a timeout. Otherwise, you may die alone and old. So this is just a little sensible advice I think I would like to give to people. So try for a few years, but keep moving. And in fact, I have to say this is built into the Indian culture. This is why we have arranged marriage. My parents always tell me, go find the person you want to, otherwise you marry whom we tell you to. Okay, I'm only joking, but only lightly. But the point really is that this is really the philosophy of life. You don't want to do things without a timeout, right? So what do you do if things never happen? Well, that's exactly the point, unfortunately, in Java 8. This was not built in. And so if you are using JDK 8 right now, you cannot use what I'm going to show you because this was introduced in Java 9. So in Java 9, they introduced two new methods to completable futures, among other things. And one of them is to succeed on timeout, and the other one is to fail on timeout. There is no real right answer for this. It depends on what you're trying to do. You could say, if I request something and it is not happening at the time I allocate, well, I want to use an alternative solution and move forward. Or you can say, I'm going to blow up. So let's take a look at the example to see how that actually works. So in this example, as you can see here, after a second delay, I was able to complete, or after a second delay, I was able to go ahead and say that it's going to fail. Let's go ahead and just do complete at this point. So if I complete after a second, clearly in this case, when I run the code, you can see that after a second, you can see the output of 10, that actually worked. On the other hand, if I were to fail after a second rather than complete it, you can see that after a second delay, it is also going to give us an error, and then we can move on at that point. But what if it does neither one of those? It doesn't fail, it doesn't complete. Well, your task that you set up may actually be pending for all the time, and you would never know that something never happened. As you can see, the process in this case terminated, but if it's not a process that's going to terminate, you're going to wait for a very long time, like forever. So what do you do about it? Well, here's an idea. What you could do here is, you could go to this future, and you can now say future dot complete on timeout. And you can specify what do you want to return when it is a timeout happens. I'm going to return a 0. Well, what would a 0 do? 0 times 2 is 0. So it's going to print a 0 in the end. And I'm going to give it a 2-second allowance. So time unit dot seconds, and specify the seconds delay. So in this case, you can see it says that complete on timeout, and after a 2-second delay, I'm going to give a result of 0 if it doesn't complete. Now, before we go deeper into this, keep in mind that a promise, a completable future, can be in one of 3 states. It can be in a pending state. In fact, that's exactly what it is right now. It's in a pending state. But from the pending state, it can either go to the resolved state, or it can go to the rejected state. But the minute it goes to a resolved or a rejected state, it would never ever change after that. So once it resolves, if you complete it, that becomes a no op. Once it rejects, if you complete it, that becomes a no op. Because once it's in a final state, you can never change it. So in other words, this has to happen before a complete or before a reject. If this happens after a complete or a reject, this has no meaning. So this is just waiting in the background for the timeout to happen, and at that point, if the event has already happened and the promise has completed or resolved, then this is of no consequence. So in this particular example, I'm asking it to resolve with a 0, but notice that I'm going to complete it successfully after a second delay. So if I go back and run this code, you will see the output of 10 because I was able to complete it within a 2-second delay, right? So because I completed within 2 seconds, it took it. On the other hand, I'm going to blow up within 2 seconds, and in this case, of course, as you can see, it blows up as well. However, if I don't complete, and if I don't blow up, if I don't reject it, now the 1 second has come and gone. Now I'm sitting there for 3 more seconds, and in that time the 2 seconds elapses. When the 2 seconds elapse, it's going to complete with the value of 0. So the third time I run this code, you can see that it is actually going to give us a 0 because we hit a timeout. Now clearly, if I complete or reject after this happens, that doesn't really matter because we've already completed with an alternative value, right? So that's not a consequence at all. Of course, it doesn't mean you have to complete all the time. In fact, a lot of times you may not. So what are we going to do? Our timeout. So our timeout says, if the time expires, then just fail, then reject. So in this case, I'm going to give a 2-second allowance for this one. Obviously, there's no data for this. Well, if I complete during the time, it's going to use my completion, as you can see. So the value is 10 at this point. Similarly, if I blow up logically, that's going to be what it is going to use. So if you look at the error message, it's something went wrong. That is the error I got potentially from a server. On the other hand, if I don't complete and don't fail, don't reject, then we get a timeout at the end of 2 seconds, and right there is the failure rejection with a timeout exception. So the moral of the story is never use a synchronous operation without a timeout, right? You always want to use a timeout, because if you don't use a timeout, if things don't go the way you expected, you're going to be waiting for a very long time, and that puts your system in a fairly uncomfortable state. Yes, please.
What about while processing, you reach the timeout and you are getting the output and it's interrupted by the timeout? Right.
So it's a really good question. So one of the things we have to really comprehend in our mind is that we live in an asynchronous world. This is a little hard. I have the same problem as you do, because my mind is wired towards what about this other task that's happening? But we got to completely separate this out in our mind. Imagine you have called upon a company that's doing work for you, and you told them to do something. And in the meantime, you have lost patience and you have taken care of something else. And they come to you and say, look at all the work we did. What is your response usually? Like, I don't care, right? Because I had my business to do and I kept moving. We need to really think about it that way. These are purely asynchronous tasks where our concern is not about the work that other tasks did. Our concern is about what we do for our process. And so as a result, you don't focus on, in a truly concurrent world, things just happen when they happen. And if your train leaves and you get on the train, you did. And what happens after that, you deal with it, right? So we have to really cope with those things in that way, rather than saying, oh, wait, I just did this, but I want to still go get the data. It doesn't work that way. So well, no, it doesn't. It'll keep going. And when it finishes, it finishes. And when it comes and delivers the result to you, that train has already left. So that becomes a no op. So all that effort that was put into it is not of any use. But guess what? That's called cloud computing, isn't it? We throw things on the cloud and then we keep moving. Our goal is responsiveness. Our goal is performance. Our goal is not optimizing resources. This is one of the models we have to get in our mind. Our goal is not to conserve resources in this case. We're throwing things on the cloud. We got a lot of processing power. Our goal is responsiveness. We want to get the user moving forward. We want our computation to be moving forward without unreasonable delays. So if other things were done and you're not going to make use of it, so be it, right? It's a mind shift in a way, right? So we have to think about it as the focus, the objective is to work on this central process we are working on, this main activity, and if the result for it is coming through, I'm going to use it. If the result doesn't come through, I'm moving with something else. I'm not worried about the other process. Those processes are not preemptible, right? So you just launch them and they keep going. When they finish, they finish. If they got on time, you pick them up. If they didn't arrive on time, you moved on with other things. That's a way to think about it. Yeah. And so with that said, we saw how to bring these together and the success and the failure. So always use a timeout, whether it's a complete timeout or whether it's or error, it's entirely up to you. And I'm not going to say one is better than the other. It really depends on your task at hand. In some problems, one may be a better suited solution. In another problem, the other one may be a better suited solution. You have to pick and choose what may make sense. Now, that's great so far, but there is a bit of a confusion in my mind when I started looking at these methods, because I was trying to comprehend what these really meant. And so what I'm going to do is to focus on two more methods here and understand what those two methods actually mean. And one of the reasons why these methods look a little bit stranger for me is I spent a lot of time in JavaScript promises. And JavaScript being a dynamically typed language, you don't have to worry about what type of data you are dealing with. You just kind of go with the flow. Well, because Java is a statically typed language, when you're mixing things together, the type becomes very critical to deal with. So let's talk about two methods. Let's start with a method called combine. But before we talk about the combine method, let's go back to our comparison we saw here with the stream. So one of the methods that you also know in a stream is this beautiful method called reduce. So what does a reduce method really do? Reduce method takes elements in the stream and reduces them to a single value, isn't it? So for example, if you have a stream, you could say strm.reduce, and you could start with the value 0, and you could say total comma element, and you could say total plus element, for example, right? Or whatever operation you want to perform in here, you could perform a reduce operation. So in other words, it kind of, what does a reduce do? Oh, it combines the values. Now you know why this is called combine. So this is obviously combining the values. So this is then combine. So what does the then combine do? Then combine is going to combine two things together. So how do we use this? To understand this, let's take a little example and play with it. Let's say we have a method which is going to return a completable future of integer. We'll call it create with the integer n. And what I'm going to do here is return a completable future, supply async, and the async is going to simply return back the value n to us. So nothing really exciting. So this is just going to return a completable future that's going to return the value to us in the future. Well, that's great so far. Let's go back over here and say this is concurrent. And what I'm going to do here is to take this create, and I'm going to call it with a 2. Well, okay, that's one completable future. We'll call it as f1 equal to. But I'm going to say f2 equal to create with a 3. But I want to combine the results of these two together. Like what? Maybe my job requires two things. A customer just logged on, and I need to find out what their current balance is. But I also want to know what their credit limit is. And maybe I need to get this from two different services. Or it might be possible that when the customer logged on, I need to get credentials about their history with the bank. How long have they had an account? Because that may give me information about trustworthiness for a transaction I'm going to allow them to perform. Maybe the history is kept in one server and the current balance information is in another server. I'm going to make two different requests. But when the two responses come together, I want to do one operation on the two values together. Maybe you will give me their current balance and their history, and I will take those two values and work with it. Combine doesn't mean adding them. It could be processing something based on two values that come asynchronously. So how do I work with it? So what I'm going to do is call create, and then I'm going to say dot then combine, and I'm going to call create with the 3. Just focus on this before we go any further. So what does the parameter say? Well, we know what's on the left of the dot is a completable future. We also know the first argument we pass to then combine is also a completable future. So in other words, we take one completable future and we call the then combine and we pass to it another completable future. Now these two are asynchronous and they go off. Like one would go off to get the customer's balance, another will go off to get the customer's credit history. When it comes back, whenever it does, when both of them arrive back, what am I going to do? I'm going to say A comma B, and in this case I'm going to return A plus B, and I'm going to return that response. So notice how when both the values return, I'm going to take this action of taking the value A and B and adding them. Now obviously the question is, what's the return type of this? The return type of this itself is a completable future, because you have taken two asynchronous work, and the result of asynchronous work coming together is also asynchronous, isn't it? So what am I going to do then? I say dot then, and then apply, and I could take the data and I could do some work with the data. It's a silly example. I'm multiplying with the 1, so we don't have to think too hard to see what it did. 2 plus 3 is 5. 5 times 1 is 5. You can pipeline it. Then accept, and I'm going to simply say system over here, dot out, and println, and we'll simply print it. So what is happening in this case is we set up two different tasks. When those two finish, we combine the result together, and then we transform it, and then we printed it, right? So as a result, these two processes could go on separately, and you can see the result is 5 now. So you understand what a then combine is doing. So the then combine is kind of like a reduced method, right? So it said, I'm going to take the result of one and the result of the other, and then I'm going to do some work with the results and yield a completable future with that result for further transformation. So this nicely falls into a chain of completable futures. Well, okay, that's good so far, but let's go a little further. What I want to do next is, I want to call the create function, and you know what that's going to do? It's going to return a 2, but I'm going to take this one, and I say then apply. And in this case, I take the data, and I'm going to pass it to create data. So what am I really doing? This is a little silly, maybe data plus 1, who cares? What would I do? So I call the create method pass a data. When it gives me the data, I'm going to make a second request with it. For example, maybe the user just logged on, and I take the user's credential and I make a request to get maybe their account information. When their account information arrives asynchronously, I take their account information and call another service. Well, question for you. What is going to be the result of this call here? Is it sorry? I think somebody said that over there. Yeah, it's going to be a completable future of integer. Who wants that? Nobody. In fact, he's folding his hands, saying no, definitely not, right? Absolutely. That kind of sucks, isn't it? This is going to be a completable future of a completable future. And to make things worse, Take that and call another method. You can even have a completable future or completable future or completable future. And that's not going to be fun, right? Well, here comes let's actually prove that it's actually true. So I'm going to say dot then accept system.out println, and when you run this, that's a completable future of completable future, right? That's why it printed that completable future inside of that. Jikes, that's not what you really wanted. That's pretty smelly. But before we go, when I looked at this, I was a little confused because in the case of JavaScript, this was not a problem. The reason it's not a problem in JavaScript is the method that you pass to then has a property in JavaScript. It can either return a data or it can return a promise. If you return a data, they wrap the data into a promise automatically for you. If you return a promise, they just pass the promise over. And I was sitting there thinking, why can't Java do this? And the short answer is static typing. In the case of JavaScript, it's dynamically typed, so they don't care, right? I mean, JavaScript is so happy you're using it, doesn't insist on types with you, right? But Java says, let me tell you what the type should be, and you have to follow the rules of the land. And so as a result, when a method returns a completable future, that's different from a method returning a data rather than a completable future. So Java says, wait, I can't handle that. What do we do about it? Well, before we answer that question, let's take a slight detour and come back to it. So the detour here is, let's go to streams for 1 minute. So let's take an example of a bunch of numbers, if you will, and given these numbers, let's just do a very simple work here. I'm going to take a function, and the function here is going to be public. Let's say a static int, a double, and this is a doublet, and this takes a number n, and all it's going to do is return n times 2. A little silly example. Now I want to look at what this method is. I would say this is a one-to-one method, right? That's what it is, one-to-one method. So what is a one-to-one method, a one-to-one function? It's a one-to-one function because it takes input n and it returns an value n. That's all it does. Well, in this case, it's a one-to-one function, and you all know what I can do with it. Numbers.stream.map, and you can say here, given a data, call the doublet and pass the data, and then you say for each, and you can simply say system.out, and you can do a print line on it, right? Println. So in this case, when you run this code, you can see the values are 2, 4, and 6, and you use the map function for this. So what does a map do? A map handles really nicely a one-to-one function. On the other hand, imagine for a minute I have this scenario where I'm going to say this is going to be list of integer, and I will call it as before and after. And what does this before and after do? It simply returns a list of, let's say, n minus 1 comma n plus 1. So this returns a number before and returns a number after. Well, we clearly know what this function is. This is a one-to-many function, right? Well, when it's a one-to-many function, what's going to happen if I go over here and call the before and after? Well, unfortunately, when I run this code, it gives you an array or a list. In other words, it's a stream of list. It's not a stream of data, it's a stream of list of data. This is, you know where I'm going with this, right? So, but I don't want a stream of list of data. I still want a stream of data. Any ideas what we can do to fix it? What's it called? That's right, it's a flat map, right? So what is the purpose of a flat map? Here's a way to think about it. Use map, so let me see if I can say it. If you have a one-to-one function. Use flat map if you have a one-to-many function, right? And of course, you really wanted a collection of data, not a collection of list of data. So what am I going to do here? I'm going to say flat map, and I'm going to go here and say dot stream on it. So when I run this, you will see it's no longer an array. It literally is that stream of data. Well, so we have a nice little flat map when it comes to streams. And that's exactly what this is, then compose. So the then compose is the equivalent of flat map. So if you know when you would use a flat map in a case of a stream, you kind of know when you would use a then compose in the case of a completable future. When a transformation gives you a data versus a transformation gives you another completable future. So when the result itself is completable future, you don't want a completable future of a completable future, you can flatten it out. So this is really flattening operation. Let's see if that's true. So I go back to this code that we had a minute ago, and what am I doing? I'm going to say compute of 2, as you can see in here, and that gives me a completable future. And I say dot then apply, and I'm going to take the data and call compute of data plus 1, and I say dot then accept, and I'm going to simply say system dot out and println right here. And when I print it out, what is this return to us? Well, in this case, of course, this create rather, not compute, so create. And so in this case, when I call the create method, you can see that the result is a completable future of a completable future. But all I'm going to do now is to simply say compose. And when I run this code right now, you can see that it's a result, not a completable future. So in other words, the return type that we had a minute ago, when I wrote then apply, this became a completable future of integer. But I don't want that. So what I'm doing instead is the following, right? So I'm saying this is going to be then compose, and this becomes a completable future of integer that we can use. So that's the flattening operation that's happening, and that's the purpose of the then compose. So in other words, if your transformation method is returning a piece of data, use the then apply, which is like your map. But if your transforming function returns yet another asynchronous function, completable future, then use the compose. So this will then return to you that completable future rather than trying to return its own completable future. So in other words, this is just going to be a pass through. It says, well, gosh, you call this, I might as well return what this one returns to you rather than box it into another completable future and give you that external completable future. I'll just give you the direct completable future so you can carry on with it. So with this, of course, you can perform more transformations moving forward. For example, I can take this one here and I can then say dot then apply. And then I can say, given a piece of data, well, go ahead and say, take this data and pass it on to data times 1.0. And you can pass that down further down, as you can see. So that works really well. Well, obviously, if I use the then apply on the top one, I cannot do data times 1.0 because star 1.0 is not an operation on a completable future, right? So that's basically the idea behind the compose method. So you can see here that we use the compose to perform this operation. So let's review what we did. We talked about the nature of the computation. We are interested in asynchronous operations. When it comes to these asynchronous operations, you want to really do non-blocking calls. It's like you want to make a call to a service. This is so true in the world we live in, isn't it? For example, you may want to talk to a microservice. From one microservice to another, you want to send a message. Obviously, you don't want to block and wait on it. You want this to be completely non-blocking and asynchronous. You fire off a request and say, hey, go do this. When the response comes back, do something else with it, and you can move on. So for that purpose, a completable future works really, really nicely. This is really built on the concept of promises. So in that regard, we need to keep in our mind the two channels we have, the data channel and the error channel, what I like to call as the right track and the left track. So if everything is going well, you keep moving on the transformation on the right track. If something goes wrong, you start moving on the transformation on the left track. You can recover and come back to the right track. You can fail and go to the left track. back, so you could be moving towards that. A Completable Future forms a functional pipeline. So when you form this functional pipeline, you are going through the series of these transformations from one promise or which is a reject or a resolve to the next one and the next one and the next one, and you flow through this pipeline. As you flow through this pipeline, you can perform transformations, you can perform actions. Transformations are using then apply, actions are using then accept. You can also combine multiple completable futures using combine. You can take a result of an asynchronous operation and perform yet another asynchronous operation. In that case, you use a compose and not a combine at that point, and you can build on that as well. And of course, we saw how we can deal with exceptions, and we can deal with exceptions. You can generate exceptions to reject a promise, or you can resolve it by using complete. Keep in mind, always use timeout. Whether you succeed on timeout or fail on timeout, either one we should always set up. Never do asynchronous operations without it, please.
Is there a way I can do something when there was a timeout on the Completable Future?
If there's a timeout, you want to do some other operation. You can, and that is basically where you could take this work. So in a way, you could think about this. Let's think about this for a minute. So you are saying, I have a operation to perform a timeout, but that computation, well, that's going to be, you could probably pass a lambda to it and do a delayed execution. So at that point, when that gets triggered, you still have to find a way to execute it. So the short answer is no, but the long answer is you may have to use a level of indirection for it. So at that point, what you could say is, well, okay, so I got this response. If I did, maybe I will start another request. The problem is whether that request itself is going to be immediate or asynchronous, you don't know. And if it's asynchronous, that may itself result in a timeout, right? So that becomes a little tricky. So you have to handle it. The API doesn't provide that directly to you, but you would have to do something for that in that case. So not quite built into it. And the reason for that is that it itself is unpredictable, because anytime you do something asynchronous, potential for it to succeed, fail, or timeout. So you have to be careful about it. So that you have to bake that into it. One alternative you could do is you could fire off a couple of them, and you could do something like a asynchronous job, and you could combine through them and see if you can process one set through it and maybe have a signal through it. But anyway, that's.
For example, I'm talking to this regular service which
Yeah.
is always working.
Right.
But if that's not responding, I want to do a backup service.
Yeah. This is quite not baked in for that purpose, right? If that is what you want to do, you still have to just start off two different requests at that point. The API itself is not going to perform that for you in terms of this. This is unlike the reactive stream API, where if one thing fails, you can start a backup service. You don't have that capability in here. At least not to my knowledge, you don't have that ability to do that. No. So that's basically what it is. We'd be glad to listen to more questions or comments. Yes, please.
Then combine. Is there a practical use of that object?
Is practical use of which one?
Then combine.
There is. A practical use is, you have given me a data, but I got to work on this data, I need information from two services. So I need to, as an example, you just logged into my service, but I need to go pull data about you from my benefits, but I also have to pull your data from the profit sharing pension plan, and I need to bring those two together to meaningfully give you a response. So I may send a request to my benefits server, I may send a request to my profit sharing server, and when they both come back with a response, I'm going to take those two responses and create maybe a report for you, or maybe look at your eligibility based on your participation in both of them.
So the object will have all the data.
Not only will it have all the data, well, it's actually two separate data. So when it comes to the combine, the key here is the combine says, I've got the second option, right? So this is create 3. So in here, A is part of the first request, and B is part of the second request. So this is the asynchronous response from this guy, and this is an asynchronous response from this guy. So in the hypothetical example I was saying, this could be your benefits data, this could be your profit sharing data. And now I'm going to make a decision here using your profit sharing data and your benefits data to combine together whatever that I'm combining together. Maybe I'm going to say whether you are eligible for participating in a particular plan at work. Well, for you to be able to participate, there's got to be something you are eligible in the benefits, something you should be participating in the profit sharing, then you can apply to this, not otherwise. So it may be a qualification criteria. But in order to decide that, I need data that comes from two different services. So that's basically, combine is really to say, I've got two asynchronous things going, and I got to bring them together. So typically that's what I would say, two different services, I want to bring them together.
Kind of a similar question. Is there anything built in for working on collections of collectible features? So like any or all?
So collections of futures, yes and no. And this is a very sticky point. So there is a function, unfortunately, it's not done very well in my opinion. So there is a all function, and all will give you either the first failure or all of them succeed. The problem really is because of static in the case of JavaScript, that works really well. Because of static typing, when you get the response back, the all will only tell you that it was done. All doesn't give you the data of its completion. So it really is not very convenient to use. When I had to use it, I had to do some extra work around it. So the answer is yes, but not as convenient as we would like it to be. But the key about all is it will, if one fails, it'll fail, reject. If all of them resolve, it will resolve saying it's done, but the result of that is a completable future of void.
In the then applied, that completable future is like the context at which you created it captured? Oh.
No. Yeah, that's a sad part. You still have to do extra coding to go back and do the work with it. So you may have to maintain a list, and you have to process it, and this is going to tell you when it's done, and then you have to get the data from it. So it's not, it was not a pleasant experience for me, at least the way I saw it working. So that's why yes, and yeah, you got to work a little harder for that. Yeah. Any other questions or comments? Yes, please.
I have one. When you use the then combine, what happens? Like we know that if it's accept happy path, we get our data. Mm-hmm. When it's rejected, we can decide to go, okay, I'm going to give you the default or something. What happens if one of the two times out? What is my end result?
Right. So if either one of them were to reject, you would be on the rejection path moving forward. Now, this itself potentially could contain an exceptionally inside of that. So you could say, if this alone were to fail, I want to deal with it separately. You could do that because at the end of the day, what I highlight over there is a completable future. So you could do a pipeline before you even get there. So in other words, the create method itself could have exceptionally built into it, and it then returns to you a completable future, and you could place it over here. So in that case, you are dealing with the failure of that alone in that exceptionally. Alternatively, you could also do exceptionally here, and if you do exceptionally here, it could be a failure of that, it could be a failure of that, or potentially it could be a failure of, well, actually in this case, because this is a separate completable future, let me think about this for a second. Because it's a separate completable future that you're passing to it, that result is pipelined in here. Yeah. So this one could be a failure here, or it could even be a failure here. Because when you are doing this processing to combine, you could potentially have some failure as well. So in other words, you may want to think about this entire thing as one, box, and whatever happens to that, you're going to pipeline from there on, and then you can build it. So you have to decide which place to put it in. You could also go even further down. You could say, from here I have a then apply, because I have more transformations to do, and then you could have an exceptionally after that as well. So it really depends on where you want to handle the exception. Yep.
Oh, so it picks up the nearest exceptionally.
Well, whenever the failure happens, it'll be picking up the next exceptionally.
Okay.
Yeah. So it says bypass all the then and get to the next exceptionally, or bypass the next exceptionally and get to the next then if it's a success. So that's how it's going to go forward.
But in between, if I produce a timeout, then basically everything is over there.
Well, so if you wouldn't really produce a timeout in between, the reason is these things usually are not going to have a huge delay in their process. If they did, they would be asynchronous themselves.
Say the create 3, I can produce a timeout over there.
Yes, that you can do. And in that case, the exceptionally, or you could complete on timeout too. So depend on what you do. Yeah.
But none of them, I mean, if it is complete on timeout, it's fine, because it will go to the then apply.
Correct.
But if it is
If it's a failure, yeah,
then
you'd go to the exceptionally. That's right. You'll go to the nearest exceptionally at that point.
Oh, it goes to the exceptional?
It has to, because you're blowing up, and the minute you blow up, it's got to go to an exceptionally.
So timeout is also considered like an
Oh yeah, it's a blow up. It's instead of you failing it, it fails it for you. Yeah, that's why in the example I showed you, it still printed the error. The error message printing was from my code.
But it didn't resolve as an exceptionally.
It rejects it. So it's a rejection. Either you reject it or it rejects it. Or either you complete it or it still rejects it. But it's still a rejection of the original promise. And then you go through the pipeline.
Oh, then this answers my question. So if the first completable future times out, I can have an exceptionally which does the backup process, right?
Well, if it's an asynchronous, then you have to still deal with that again.
Okay.
Yeah. Because once you're in the pipeline, that's another execution you have to perform. Right? And that exceptionally, that could time out too.
Yeah.
Which means recursively you have to handle that. Yeah, but one of the things to really think about is completely make it as a abstraction, right? You're saying, here's a little box, I don't care what's happening inside the box. When the result comes out of it, I'm going to deal with it. And then if you're saying, well, that itself may time out, and I want to go to an alternate service at that point, then within that build the exceptionally. And then that way, when that abstraction is given to me, I don't have to worry about it. Otherwise, my code becomes extremely messy, right? Because if you expose that detail, then everywhere you're going to have these, exceptionally, and then the code becomes unmanageable. So that's one of the things to think about is abstraction. So you're saying, hey, this is a little box, it's encapsulated, and I want to build behavior into it. And then that you can do with putting a timeout on it. And then that way, what I'm going to get is a data, whether the data is from the original or from the backup service I got. That could be the case. But if you leak that into your pipeline, it becomes incredibly hard to deal with.
So if I understand it correctly, like if both the creates blow up and we handle, in both the create, like we handle it exceptionally, the exceptionally and the combine won't work.
Well, no, it depends on what you do in that exceptionally. If that exceptionally blows up, you will get to this exceptionally. If that exceptionally resolves, you won't come to this exceptionally. Yeah. Again, it's purely the pipeline, right? Every stage, whatever happens, resolves the next stage in it. If you are okay, then the next, then. If you're not okay, then it's an exceptionally. So, but every stage you have to decide that. Then apply could blow up also. Right? If the then apply blows up, you'll go to the next exceptionally. If the then apply didn't blow up, you'll go to the next then, whatever that could be. So every stage decides where you're going to go to the next stage.
What will happen if we put a try-catch here?
So the concept of try-catch doesn't apply in this pipeline, because you can't stick the try-catch in between the pipeline, right? So try-catch is a imperative programming idea. Here we are dealing with a functional pipeline. They are mutually exclusive. So there is no way to put a try catch in here. You can put a try catch inside one of the computations, but that's within the block. And whatever happens within that, right? That's a encapsulated piece of code. And if your catch suppresses everything and returns a result, then you are resolving. If your catch in turn blows up, then it becomes exceptionally at that point. So the try catch can only be within these stages. You cannot have a try catch across. That's one of the things to think about, is that exception handling is an imperative style of programming idea. Completable future pipeline is a functional idea, right? We're doing a functional streams, so they don't go hand in hand. They're completely orthogonal to each other. So the try-catch concept is more tactical than global scope in this case.
So what is the abstraction for, in that comparison you showed, what is the abstraction for completable future? I mean, it's not exactly a stream even.
It is a stream with a 0 or 1 piece of data. It's a stream with a 0 or 1 piece of data. Stream can have 0, 1 or many. This will have 0 or 1. Stream cannot handle an error, whereas this has 2 channels, one for error and one for data. So this is more like a stream, but not for stream of data, right? It's a pipeline, that's what it is. And a pipeline can be a stream pipeline, or it could be a completable future pipeline. The stream pipeline only transmits data. It doesn't transmit error. If you want to transmit error, you have to build it on top of it, right? Stream itself doesn't give you that. A stream has only one channel, which is the data channel. And in the data channel, if you want to send error, you have to design for it yourself. Stream doesn't do that. Whereas here, you have the 2 channels. So this is why it's built on the same notion like a stream is. But a stream only contains that part, the top one. The stream doesn't have the bottom part. And the stream can have any number of pieces of data that goes through, 0, 1, 10 million, who knows how much data can go through it. Whereas you're saying, okay, that's great, that's a stream pipeline, but this one has 2 channels. So here's a way to think about it. If you think about it, a stream is 0, 1, or more data, right? On the other hand, completable future is data or error. That's what you're getting. On the other hand, if you look at a reactive stream is again 0 or 1 or more data. So there's a commonality here between reactive stream and streams. However, what is funny though is streams contains only 1 channel. Completable future has 2 channels. Reactive streams, on the other hand, has 3 channels. So because they have a data channel, an error channel, and they also have a complete channel. So you can see how they're not like disjoint, there is overlapping between them, right? In terms of they're similar in some aspect, different in other aspect. You would use this when you want to stream data. You want to use this when you want to stream data, but potentially you could have errors that you want to handle too. Whereas this is purely for like a request response. You're not streaming data in this. You make a request, you get 1 response, or you get an error. So that's kind of they don't fit entirely into it to say they are like this. That's why we can draw comparisons, but we also have to draw the places where they are different from each other. They don't quite fit into it. Yep.
What would be a good example, like when to use completable future versus an Java 2?
Purely, this is asynchronous call request response. I want to send a request to your server, and you're going to send me a response, right? So this is a typical REST calls, for example. Whereas this one is where I've got a server which is going to send me data about a particular stock price for the next 2 hours, and I want to start processing it, right? So that's an example of where I'm not interested in a request and response. I'm interested in processing a stream of data, and you are going to push the data towards me. I'm not going to request it and get the data back from you. So as a result, you could be sending data. I could be connecting to a device that's going to monitor maybe a door. And if anybody leaves the door, I want to know about it. It could be a security device. It could be a flight, and I'm interested in monitoring this flight over the next 10 hours. That's kind of where the Stream API really comes in, because we're interested in a stream of data. Potentially, you may have a database with 7 million rows of data, and I want to do pagination of the data. Well, databases now are giving reactive APIs for that purpose. So you go to the database and say, give me all the data that corresponds to people living in the city, and they're like, well, are you ready? We're going to give you, and you're like, okay, give me 200 rows, and then give me another 200. This could be streaming that in batches. So that could be a reactive solution. On the other hand, hey, I want to open a file and get the content of the file. It's a very small file. Or I want to make a request and say if this is a valid user on your system. I want to make a request and authenticate this user. I want to make a request and get the user's account information. These are purely RESTful calls, asynchronous calls. There's no stream of data. You have a failure, or you have a success, or we are pending. So that's why this is more of a request and response rather than a stream of data. So that's why you have a data or an error. You don't have a stream of data. So that's the biggest disconnect between the two. Yeah, please.
So going back to the try catch for a second, is it fair to say that part of the reason it works that way is because you have a non-deterministic thread that reactive pipelines can run on? So you not necessarily know what stack to try and catch on.
Well, to be fair though, I would say I want to believe that's the case, but not entirely true. I'll say why it is. The reason is, let's go back to JavaScript for a minute, right? When you're dealing with JavaScript, you have promises. Promises is a function of pipeline. But then JavaScript introduced async and await. And the reason they introduced async and await is they want to give you the try-catch model. So promises are the functional asynchronous pipeline. Async await is the imperative asynchronous processing. This is where coroutines and Kotlin is taking you towards also. So the reason why we don't have a try and catch is not because asynchrony, because potentially you could be in an asynchronous model and jump back to the catch block when that fails too. The reason distinctively in my mind is imperative versus functional, right? In a pipeline, you can't insert a try and catch. Whereas in an imperative code, you can insert a try and catch. So this is where the fundamental difference comes in. We were having this pendulum switch back and forth. We are like, hey, this is awesome, we can do functional. And then we realize dealing with exception becomes really a nightmare. In a world where you have to deal with really pure functions, this works really well. In an impure world, this becomes a burden. And coroutines and async and await are saying, well, if you're living in this impure world, but you still want to do asynchrony, we'll give you a different programming model so you don't have to hurt yourself so much. So I think this is where the trade-off is. And I'm beginning to really enjoy this trade-off where we kind of rush towards this and realize that while this is great, this is not best for everything we do. And then we realize this extreme is not perfect, that extreme is not perfect, but then a middle ground seems to be much better, and you can swing functional when it makes sense, you can swing imperative when it makes sense. I think that makes really good sense to balance out and take the trade-off. So that is why the programming models excite me, because they question our assertions and say, well, this is great when you're living in this constraint, but the minute you leave that, it's not going to work really well. So to her question, she's right. You can look at try and catch, but you're forced to make it so tactical within those functions. But if you really want to bring the try catch outside, your completable future or promises is not the solution. Async and await is the solution at that point. Please.
When you're doing unit testing of completable features, have you found a good library or a mocking of completable features so you don't find yourself actually testing Java when you're trying to just test your code?
Right.
I've found that testing completable features straightforward. But maybe I just missed a library or something that makes it simpler.
Yeah, so no, that's a really good point. One of the things I would first of all say is we should definitely isolate these pieces of code into specific methods. And when we do that, we can unit test those methods synchronously. Then, after doing that, what it really comes down to is that these, I view them more of an integration testing than a unit testing per se in that regard, right? Same thing with the stream pipeline. When I'm dealing with the pipeline of a stream, if I'm trying to test the methods that I'm using in the stream with the stream, that backfires on me. So instead I would write unit test on the methods separately, and then I would say these are more of a integration test for me if those methods are really complex and have side effects, but they shouldn't in general in the case of streams because side effects make it really, really hard. So in that case, when it comes to these completable futures, you want to be able to mark away those functions, and then be able to test your pipelining to see if they are handling things properly. So yeah, it is gnarly, there's no doubt about it, but we can minimize the pain by modularizing quite a bit and reducing the complexity in the pipeline itself.
Do you find that if you were doing quite a bit of chaining within a completable future paradigm, and you're then abstracting out the individual methods into their individual methods, is it harder to read? Because
actually, it's easier in my opinion.
Streams, like it's all very much there and it looks very beautiful, but if you start busting out into methods, maybe it might look visually kind of difficult, but...
Well, actually, I see it the other way around. And the reason I say it the other way around is, the minute you give me a lambda, I have to dig into the lambda to know what the lambda is doing.
Yeah.
If you give me a method reference, I'm able to abstract it out much more easily. So typically I use a method reference, and it actually improves readability because of that, rather than having the lambda. In fact, as a coding standard, I disallow multi-line lambdas. Yeah. Please.
More of a design question, maybe I'm wrong. So the streams and completable future both use common fork join code. Like streams to me sounds more like a CPU intensive process, so it makes a good choice to have a common fork join code as a default. But completable future, I mean, you cannot always relate asynchrony with slow running process, but most often that is how people tend to relate them. So for a naive programmer, I mean, yeah, they do have extensibility that you can give your own code, but if they're not really using it, then they're actually screwing up both streams as well as completable future.
Right.
One runs slower,
Yeah.
and other is a CPU.
Yeah, the answer I would give is there's no naive programmers. That's as simple as that. That's one of the things I always beg to differ. When people say that I cannot trust my programmers, I have a bigger problem to deal with, right? Because when we are dealing with complex systems, we cannot throw people who are unfamiliar with things and tell them, get me the results, but don't worry how things work. I think our profession is really a profession. We really need to take the time to learn and get better at our skills. If we are saying, I don't want to pay for people who are skilled, and I want them to not know what they do, and I want to throw things together, there are certain things you can do, but there are certain things you shouldn't do, right? And anytime you deal with threading, it is a dangerous thing to do. And we have to really take the time to understand how things work. That's where I beg to differ, that I don't think I can hire people who don't have to know stuff and things just magically work for them. Maybe that'll happen in the future, and when it does, I bet you humans won't be needed at that point to do it.
Can we do one more question?
I have one, it's more like you're changing the subject. Thinking about retrieving data for my classic user, right? I need a different type of data. I have 2 different or 3 different endpoints that I'm calling a REST. I want a retry on each one at least 3 times before calling it the data. So inside my method, the imperative method, I implemented a for cycle as a very simple 0 to 2 to do 3 times a call if I'm not successful? Is it advisable to set up a completable future with a timeout that say, even with the 3 attempts, it should be done in 35 seconds, okay? Is it advisable to set up a timeout like that and then go through the thing? And what happens to the thread that is actually now communicating via socket? Will the thread be terminated, the socket be closed?
No.
What is a safe way to do that?
There is really no safe way to do that, because if you terminate on timeout, that request will eventually fail. And the really short answer to that is you probably want to built in circuit breakers to deal with it, so that it'll fail fast. But otherwise, you're going to be spinning requests that's going to hold on to resources. There is no real good answer to deal with it. So if you're going to go that route, I would say build it with circuit breakers, so that knowing that it failed, you will fail fast, rather than having to wait for that duration to know.
So in case of a code like this, you need to put a good comment in there. Be careful, because when you see only the method that actually does the socket communication, this is part of a larger unit, and make sure that you fail fast within this.
Yeah, or you have to document it. Whether comment is the way to document is a disputable fact, but you got to document that behavior in a meaningful way, so that the programmer can know what the code is doing. Yeah.
Thank you.
All right. Thank you. Thank you.